Okay, so good afternoon everyone and welcome to this webinar from the Business and Local Government Data Research Centre with Professor Andrew Lovett from the University of East Anglia. Today Andrew will be discussing the results from his recent research which considers the green infrastructure provision in the east of England. He will look at what's meant by green infrastructure and give some examples of how local authorities have worked with that data and how it can be analysed. Andrew will speak for about 30 minutes. He will then address any questions that you've got at the end. So if you can save up all your questions and pop them into the question box at the end, we can go through those then. You can submit your questions at any time, but we'll save the questions to do together at the end of the webinar. So what I'll do now is I'll pass you straight over to Andrew and he can get started.
Okay, good afternoon everyone. Thank you very much for joining this webinar. Thank you for the introduction, Kirsty. So I am part of the team working on the Business and Local Government Data Research Centre project. I'm a geographer by background. I've worked at the University of East Anglia for over 25 years. I've always been interested in things to do with quantitative geography and GIS, and then the last 10 years in particular, I've worked a lot on applying different types of spatial data analysis techniques to different types of environmental and land use data. And when we set up the Data Research Centre project, we created one theme that was going to focus on issues associated with sort of spatial data. And we decided as an initial focus for that, we would look at some of the issues associated with green infrastructure and how you could map that in different ways using different types of data sources, what some of the comparisons of those data sources would be, and what some of the uses of that information might be. And what I'm going to talk about today is where we've got to with that sort of work so far. I'm focusing on example applications in the east of England, but the type of method that we've developed, and I think some of the issues that we've encountered, are the sorts of things that would apply anywhere in the country. Certainly the method we've been developing, you could implement anywhere else in Britain. So to begin with, I think it's useful to say a little bit about, well, what do we mean by green infrastructure and why might you be interested in it? The slide you can hopefully see on the screen now comes from the Devon County Council website. And it's quite a nice, I think, diagrammatic illustration of different types of green infrastructure. If you want a sort of more formal definition of what green infrastructure is, one of the definitions used by Natural England in their reports is the network of multifunctional natural and semi-natural features, green spaces, rivers and lakes, that intersperse and connect villages, towns and cities, and are integral to the quality of life in sustainable communities. Green infrastructure is essentially an example of what you would now refer to as natural capital. It's a natural asset that supports a range of ecosystem services that provide benefits to people. So, for example, green infrastructure provides recreation, aesthetic value, habitats for wildlife, different sorts of environmental services such as flood defense or absorption of air pollution, climate regulation, and so forth. And there is a lot of research I'm not going to talk about today, which has found that in different ways, proximity and exposure to green infrastructure is important for health and well-being. Information on the extent and types of green infrastructure has become increasingly important in the last few years for many different sorts of planning purposes. And actually, it's been highlighted again earlier this month in the publication of the government's new 25-year environment plan for England. There is a section in that document which talks about the need for additional investments in green infrastructure as part of sustainable development. It talks about the need for new standards on green infrastructure and so on and so forth. So there's a lot of interest in this topic. But one of the reasons that sort of led us to identify this as a research area to work on was something that was originally raised with us by a member of staff in Essex County Council, because one of the problems that they had was that they wanted information on green infrastructure on a county or regional scale, and a lot of the data that existed had come from previous green infrastructure data sets that individual local authority districts or unitary authorities had created in the early thousands in response to the government's PPG 17 requirement. And one of the issues that a person in Essex County Council raised was that they had very good data for some local authorities and much poorer extent of data, if any at all, for others. And this created considerable difficulties when you were then trying to look at the extent of green infrastructure more strategically and trying to assess how it varied from place to place. So we went away and we looked at this issue, and we realized that it was a problem that existed in a number of different parts of the country. And one of the other sort of data set areas that we were also interested in was the potential for using the crowdsourced data sets like OpenStreetMap. So what we developed was a sort of series of research questions which we wanted to try and address. So we wanted to try and see if information from OpenStreetMap could help to fill this gap in terms of providing green infrastructure databases at larger geographical scales. And then as we've worked on trying to do that, obviously other new data sets have appeared. And in particular, last summer, the Ordnance Survey released their Open Greenspace product. Now that has a particular objective. It's particularly trying to look at areas that might provide recreation access. And that's important, but you want to see how it possibly compares with other different definitions of different types of green infrastructure. So what we have done is essentially try and develop a method where we're working with OpenStreetMap data and combining it with other data sets to produce a green infrastructure database on a regional scale. And then we also want to see how that database compares with other sorts of potential green space data sets like the Ordnance Survey one or the Marine land cover. And we've worked with several local authorities to do this. So we did some initial trial work with Essex County Council, developing a database for Essex, particularly to support their growth and infrastructure plan. And more recently, we've been working with the county councils in Norfolk and Suffolk So we now have another iteration of the data for Norfolk, Suffolk and Essex. Some of the results that I'm going to show you today essentially derive from that database. So that's what we've been trying to do and the questions we've been trying to answer. We wanted to make use of OpenStreetMap. Many of you are probably familiar with this database. It's an example of volunteer geographical information. It started in the UK in 2004, and it was inspired by the success of Wikipedia and some of the predominance of proprietary map data in the UK at the time. It's grown enormously since then. It's got worldwide coverage. There's over 3 million registered users. The example that you can see on the screen at the moment is OpenStreetMap for the area in Western Norwich around the university. So you can see the UEA in the center of the screen and the types of features that are there. It's a publicly available data set. It's open data. Anyone can freely copy and download and adapt extracts of it, provided there is a suitable acknowledgement. We thought that this potentially could be a very powerful data set to use and adapt for mapping green infrastructure data sets. So we wanted to explore what was possible with it and see how it compared with other information, and whether you could use it by itself or whether you needed to combine it with other sorts of, for example, Ordnance Survey data sets. And we initially did this on a sort of trial basis in part of Essex, actually in part of Basildon, because that particular local authority had their own individual green infrastructure database that we could use as a kind of verification means of comparing the different sorts of data sets that we were working with. Lots of different studies have now looked at OpenStreetMap for different parts of the world, and it's a very powerful resource, but it's got two particular issues that you need to be aware of when you're working with. Firstly, because it's crowdsourced, the extent of the content can vary quite a lot geographically, often even within quite short distances. So the slide that you can see now on the screen is actually from part of the city of Norwich. It's the southwest of Norwich. But the thing that starts to become immediately apparent is that, for example, there's much more detail in terms of building outlines and so forth in the area to the west of the A140, which is actually the Norwich Ring Road, than the area to the north and east of it. And this is a very common phenomena with OpenStreetMap, that you get these geographical variations in extensive detail. So that's one issue that you need to be aware of. The other issue that you need to be aware of is that because the data set is crowdsourced, the same type of feature, a woodland or a park or some other kind of natural area, might actually be defined in different sorts of ways using the types of tags that exist in OpenStreetMap in ways that vary between different contributors. So if you try to identify a certain class of feature in OpenStreetMap, sometimes you've got to search across a range of different tags to actually find features that physically would look the same, because they've been defined in different ways by different contributors. And this is something that you can work around, but you need to be aware that it's an issue. So what we've needed to do is develop a way of combining different data sets. We found that simply relying on OpenStreetMap alone was not sufficient. So we then tried to look at ways of comparing and blending OpenStreetMap, particularly with open source Ordnance Survey datasets. Unfortunately, those do not always have the necessary spatial and attribute detail that you would need in urban areas. So the methodology that we've ended up developing is the kind of approach that you can see described on the slide here, where we are essentially using OpenStreetMap as one source, and then we're using the Ordnance Survey MasterMap database, which is available, for instance, for universities and research purposes from EDINA, and is available, for instance, to local government through other licensing arrangements. And we are essentially extracting sets of features from both of them and then unioning them together and then producing an overall green infrastructure data set from that. When working with OpenStreetMap, we found that rather than taking the data sets directly from the OpenStreetMap website itself, it was easier to take extracts from GeoFabric, which is a German company that produces, if you like, cutouts of OpenStreetMap data for different areas. It's just a lot easier to work with. But you can see the kind of approach that's described here. It's not particularly technically complicated. It involves clip operations, it involves different types of selection operations, and then some overlays. But it gives you a means of creating a combined data set. And essentially what we're trying to do here is blend together the strengths of the two types of data. Because with OpenStreetMap, you've got coverage that can be spatially variable. The attribute detail can be really excellent, but there's definitely some subjectivity in terms of how different sorts of features are defined. As it exists at the moment, Ordnance Survey MasterMap has excellent spatial accuracy, so it can help to fill in some of the gaps that might exist in OpenStreetMap in terms of coverage, but there's limited detail on certain types of attributes. So one of the terms that's used, the descriptive term and so forth, is a bit limited in terms of the types of features that you can identify, whereas something like OpenStreetMap gives you more differentiation of what those features are. I know that Ordnance Survey are working on revising some of the terminology of those features so that this might change in the future. But our experience from doing this and comparing it with other local authority databases is at the moment you really need to blend these two together to produce a good quality output. So the kind of approach that we've adopted, here's sort of very simple kind of example with different types of features. So we have a small area, we've extracted different types of features from the OSM data on the left-hand map. We've combined that with the MasterMap data, where you've got, as you can see, some differences in coverage. And we've then ultimately linked them together to combine and produce an overall representation. And we've done that in such a way that our output database identifies the sources of the feature and the different ways that they're classified within it, so that we can query it in different sorts of ways. So now what I'd sort of like you to get a sense of is what that kind of data looks like. So on the screen now you can see an example of that data for the area around the city of Norwich. It's got the kind of urban boundary of Norwich on there, the main roads outlined in black, the rivers that run west to east across the area, and so on and so forth. And we've got a large number of categories of different types of green infrastructure. But what we've done for the purposes here is we've grouped them into 8 higher level categories. These come from some habitat classification work that's currently in progress for DEFRA and Natural England, and it's particularly linked to the Innovate UK SPADES project, which is all about spatial decisions on ecosystem services. So you can see that we've got different types of areas in terms of parks and gardens, areas that are classed as sort of productive spaces, sports facilities, urban greening, small-scale food growing, allotments, and things of this sort. So that map gives you a sense of the kind of scattering of green infrastructure around Norwich. I think it's quite useful to compare that map with the next one. This is what you get out of the Ordnance Survey Open Greenspaces database that was released last summer. This is particularly focusing on areas for public recreational access. So the underlying definition is a little bit different, but you can see that there's different types of feature identified. The resolution with which they're identified is a little bit different. It's picking out larger polygons of land in some cases. There are some sorts of gaps in that definition. The one that is particularly noticeable is that, for example, this area of Norwich to the northeast of the city centre is called Mousehold Heath. It's publicly accessible land, but it hasn't made its way through, in most cases, to the Ordnance Survey dataset. So I know that the Ordnance Survey are working on producing other iterations of this dataset, and I'm sure that the coverage of it will improve. But there's definitely differences between that definition and the kind of definition that we tried to produce. We then wanted to sort of look at how these different definitions compared on a regional basis. So I have a set of 3 maps for you here, and what we've done here is we've got the database for Norfolk, Suffolk and Essex. We've got a set of geographical units which are actually the local authority districts and unitary authorities, and we've calculated for each of these what percentage of their area is defined as green infrastructure under the different sorts of definitions that we've been working with. So in the left-hand map, you can see the distribution of the Ordnance Survey Green Infrastructure Database. The middle one shows the distribution of our blended Ordnance Survey MasterMap and OpenStreetMap database. And the right-hand one shows green infrastructure features classified from the Careen Land Cover Data 2012. And there's, some quite obvious differences in extent. So, for example, the Ordnance Survey Greenspace database, the total area in those 3 counties is about 23,600 hectares, about 1.8% of the total area of the 28 local authorities in Essex, Norfolk and Suffolk. So that's about 2%. The OpenStreetMap MasterMap Blend covers about 255,000 hectares. So that's about 19% of the region. And the reclass Careen land cover covers about 160,000 hectares, about 12% of the region. One of the issues with the Careen land cover is the underlying spatial resolution. So one of the reasons I think why that percentage is not quite as high as that for the OpenStreetMap and MasterMap Blend is that because it's got a coarser resolution, it's not picking up some of the smaller and more irregular green infrastructure features. You can also see that there's a little bit of a difference in the geographical pattern across the three maps. So, for example, the open Greenspace layer from the Ordnance Survey has a very strong urban focus. It picks out the city of Norwich, the city of Ipswich, and some of the quite built-up areas in southern Essex around London. The other two maps, the Careen and the OpenStreetMap and MasterMap Blend, are much more strongly geographically correlated. If you actually take the individual percentage values for local authorities and you do a Spearman rank correlation between them, you get a correlation of plus 0.7. So there's a strong positive association between those different distributions. So you can see straight away that different definitions of green infrastructure are giving you slightly different sorts of patterns, and they may have different sorts of implications if you use them for planning and policy formulation purposes. If we want to work with something like a blend of OpenStreetMap and say some kind of Ordnance Survey database, we need to understand a little bit more about the makeup of that data and how you can interpret it. So one of the things that we've then gone on to do is to focus in on that database in a little bit more detail and map out the sorts of features that we're only getting picked up in OpenStreetMap, and you can see those in the left-hand map on the screen, and the sorts of features that are only being picked up in MasterMap. Okay, so you're starting to see which source is contributing relatively more or less in different geographical areas. Okay, so of the 155,000 hectares in the OpenStreetMap and MasterMap Blend layer, about 46% of that area you actually get from both source layers. About 26% is only in the OpenStreetMap, and about 28.5% is only in the MasterMap. And if you look at the maps and you look at the percentage values, you can see particularly that, for example, the distribution of features only in OpenStreetMap, it tends to be higher in some of the urban areas like Norwich, Ipswich, and particularly in some parts of southern Essex, particularly again some of the more built-up authorities closer to London. And not surprisingly, the contribution from the MasterMap database alone has a slightly different sort of distribution. It interestingly seems to vary a little bit between, for example, the city of Norwich. It's rather higher in Norwich than in Ipswich, but as a general rule, it's higher in the more rural parts of the region, particularly in parts of Suffolk and parts of Norfolk. So there's a difference between the different sources, and I think this just illustrates the need at the moment to work with some kind of blend of these different types of data. What we've then gone on to do is to look at how these different data sets can be compared with other kinds of socioeconomic characteristics. It's known, for instance, that participation in crowdsourcing activities like OpenStreetMap is likely to vary between areas according to, for instance, socioeconomic status and so forth. So we've done some very simple calculations here to look at how those different types of data vary in their associations with different socioeconomic variables. So we have in the rows of the table that you can see different sorts of measures of the extent to which the OS Open Greenspace as a percent of local authority area, the Blend database as a percentage of local authority area, Careen as a percent of local authority area, and then the percent from OpenStreetMap in the OpenStreetMap and MasterMap blend. Both of the first two databases have quite a strong correlation with population density. There's higher percentages of green space identified in those databases in more urbanized areas. Something like Careen shows a slightly different sort of pattern. I was quite interested to see what sorts of correlations they might have with population change. What does this suggest about relationships between development, projected population change, the age of the population, and so forth? There are positive relationships with some of those sorts of things, but they're not actually statistically significant. And then the last column here is a correlation with the index of multiple deprivation. And I think the important point here is that you've got quite a strong, significant negative correlation between that index of multiple deprivation and the percentage contribution only from OpenStreetMap in that blend. In other words, areas that are more socioeconomically deprived, one of the characteristics of the green infrastructure database that we can compile for that area is that it has a lower contribution from crowdsourced OpenStreetMap sources. So that is definitely something that you need to be aware of. So I think we can sort of say overall that we've created a blended product that can identify more green space than those other two data sets, although clearly the OpenStreetMap, the Open Greenspace data set produced by Ordnance Survey was designed for a slightly different purpose. It's focusing very much on accessible recreation. What you need to be aware of when working with these types of data is that they have got certain types of socioeconomic associations. So if you're trying to interpret them for different purposes, those potentials for bias need to be kept in mind. And I think one of the best ways to try and address that is by not just simply relying on a single data set, but blending several of those different things together. So this is what we've done so far. What we're now looking to do is a number of different things. We have a mechanism here, and we have the ability to generate this kind of data set for other geographical areas. We're very interested in trying to compare the areas we've worked with so far with, for example, rather different sorts of local authorities, especially if they've got their own green infrastructure database that might give us a basis for comparison. There's clearly scope for looking at other types of socio-economic associations, e.g. age structure, education level, proximity to education institutions like high schools, colleges, universities, and so forth. What we're also looking to do is try and see how these types of data can be used by local authorities. So we're now working particularly, for instance, at the moment with Norfolk County Council to see how we can use these data sets to assess the need for investment on additional green infrastructure in areas that have been targeted for new housing development. If there is an area that's been designated for that purpose, what's the extent of green infrastructure in the area around that site? How does it compare with the Natural England green infrastructure standards? And for instance, what additional investments in green infrastructure might be necessary? The same kind of approach could be used to look at impacts of such infrastructure developments on Natura 2000 sites. If there's going to be an impact from infrastructure development such as housing, roads, or other construction on sites of nature conservation importance, what other investments can perhaps be put in place to reduce the pressures on those sites of conservation importance? And another area that we're now starting to look at in more detail is, having got these sorts of databases, what kinds of associations can we find, or what can they help us detect in terms of associations with health and well-being? And we're looking to work with a number of different businesses involved in healthcare provision to try and assess those different sorts of issues as well. So thank you very much for your interest. I hope you found it interesting and helpful and useful. And if you can send any questions that you would like through to Kirsty, I'll do my best to try and answer them. Thank you very much.
Thank you, Andrew. That was really interesting. We have already got a couple of questions that have been submitted, so we'll just get straight on with those. A few people have asked if the presentation will be available afterwards, and it will be up on our website where you can watch the recording again, and so will a copy of Andrew's slides. So if we get into the first question, somebody's asked, how can developing countries such as Nigeria benefit from your experience implementing green infrastructure such as this?
Okay, that's a very challenging sort of question. I think you have to, you have to start to look at the different sorts of sources that are available. Something like OpenStreetMap exists for the entire world. The coverage is very mixed from one country to another, but there are definitely scopes for using platforms like OpenStreetMap, perhaps involving local schools or colleges, and getting communities involved in actually mapping their neighborhoods and the green infrastructure that's present there. I know of a number of community projects in, for instance, Indonesia, where that kind of thing has been done. So that would be one thing. But then the second thing that I would do is I would try and make use of all the developments that are going on at the moment in much higher resolution satellite imagery and associated data than existed even 5 years ago. You think that what's going on with the European Space Agency's Copernicus program, the satellite data that's coming out of that, information that's coming out of various US geological survey programs and so on and so forth, there is the ability to create those kinds of databases. I think the thing that I would say from our experience is probably the value of trying to look at ways of blending those different sorts of things and comparing data sets rather than simply relying on one source.
Brilliant, thank you, Andrew. So we also have a question that's been submitted asking whether if you used CEH is LCM 2015 data set, whether if that provided greater resolution data to inform your outputs compared to the Careen 2012 one that you used. So I suppose it's a wider question if you use different data sets. I'm assuming they'll have
to be honest, that's an extremely good question, and it's a comparison I haven't made yet, and it's something that I clearly should be thinking about doing. When we were working on a lot of this, some of the LCM 2015 data wasn't, for example, available on Environment Digimap, so I concentrated on Careen because I could get immediate access to that. I know that LCM 2015 is now available on Environment Digimap, so that comparison can be done, and it would be a very sensible one to do.
Okay. Brilliant. So following on from that, how could you use green infrastructure data like this to inform flood risk management? The questioner is asking specifically schemes that look to work with natural processes and maximise green space for flood storage. Okay.
That's also something that, again, features very strongly in the 25-year environment plan. I think what this kind of database might help you do is to look, you'd need to combine it with other data. You'd need to combine it on, for example, terrain data, which would give you an idea about patterns of, say, surface water runoff and so on and so forth. But you might be able to use, for instance, the need to try and increase flood resilience in an area and the need to try and increase green infrastructure provision to make an argument for investment in new features that would actually be multifunctional. In other words, they could provide green space access for recreation, but they could also be designed in such a way that if there was high surface water runoff, water could either be diverted into them or they would allow water to infiltrate in the ground. You could try to think if you could build some kind of sediment trap in part of the area. You could have a wetland feature that would absorb more water and so forth. I think one of the ways of trying to think about that would be to look at these kinds of the scope, if you like, for multifunctionality.
Brilliant. So we've got a question here asking about specifically about the Ordnance Survey Greenspace master map and how it deliberately omitted typologies that had already been mapped, such as country parks and nature reserves. And were you able to reflect these in the other data sets that you used?
We should be, yes, we should be able to include certainly some of the country parks and things. I think, you know, the Ordnance Survey have produced a first iteration of this data set, and I think they're very aware, having done it, that the coverage is a little bit variable in places, both differing geographically and also in the types of features that they've included, or in some cases not included. My understanding is that they're very definitely likely to be working on subsequent iterations of this data, because there are, even if you took the public recreation access definition and you know certain areas reasonably well, it's not too difficult to identify features which you think, well, you know, why hasn't that been included and so forth. Yes. What we have not tried to do yet, our definition has not tried to specifically include public access, it becomes unfortunately quite problematic to try and identify exactly what is publicly accessible in some cases. It's not too difficult with certain sorts of features, but even, for instance, trying to put together information on public rights of way on a larger than county basis is at the moment still quite a problematic thing to do. There are very good individual county databases, but they all tend to be done a little bit differently. And actually the work that would be quite a job at the moment to assemble those together into a regional or national database. And that would be another important thing to try and do, particularly if you wanted to try and assess wider countryside access.
Okay, so following on from that, we've got a question asking, how did you approach mapping and analysing linear green infrastructure such as canal towpaths and public rights of ways?
Okay, well, in some ways, it's the same kind of thing. You can pick out certain sorts of linear features and paths. We have focused more on polygon features than linear features. We wanted initially to try and focus on certain types, for example, of ecological corridors. And we found that that type of feature was very difficult to identify in the types of database that exist at the moment. They are that feature is very important from a sort of ecological planning perspective. It's really quite difficult to identify that consistently from this sort of thing. You know, we certainly can pick out different sorts of linear features, but the databases that we're working with are definitely polygon databases rather than line databases.
Okay, I think this might have a similar answer. A question asking, what role do you think that street trees and small areas of woodland have to play in green infrastructure provision? They're asking specifically in with reference to new housing developments.
Yeah, I think they're very important. I think it's the kind of thing that's quite difficult to identify with the sorts of databases that exist at the moment. I think the really important development there could potentially be the work that's now ongoing to produce a national LiDAR coverage, light intensity detection and ranging, because that will give us a national coverage of much higher resolution topographical height information. And if that's done in such a way that you have both a surface model and a bare earth terrain model, the ability to differentiate those two will make it possible to map out those kinds of vegetation features consistently in a way that I think is still quite difficult at the moment, certainly across big geographical areas.
Okay, brilliant. So this is a bit of quite a big question. So developing local projects to contribute their own mapping is really exciting and an attractive possibility. But this questioner would ask if you could say something about the kind of timescale that's involved in any meaningful local projects, any existing tools and case studies that they might be able to use to help educate and inform local projects and potentially to speed up the process.
Okay, I think it depends a little bit whether you want to do the kind of local mapping or whether you want to sort of extract data that already exists. I think with something like OpenStreetMap and a set of rules, it's not particularly difficult to extract the green space features from that area. So, you know, in effect, the kind of approach we developed is almost like a bit of a recipe. If you're if your coverage for an area you felt was reasonably good, extracting the features out isn't too difficult. If it's more a case that you want to map green space features for your local area or other types of features for an area, I would say that a platform like OpenStreetMap is very good for that. And there is a lot of, I think I would sort of recommend looking on that database and some of the wikis and support that are associated with it, because it's really not very difficult with either smartphone apps or a small handheld GPS receiver. Probably smartphone apps would be the most mass market thing now, to have a tool that in effect, you know, would give you your mapping capability, could store features that you could collect through field work and then upload to a platform like OpenStreetMap. That would be the way that I would go about trying to do it.
Brilliant. And are the blended maps that you're working on with your colleagues, we've got some questions asking if they would be available to be used by other people, such as Ordnance Survey's PSMA agreement holders.
Yeah, I think if people had the Ordnance Survey licensing in place, then there is no issue with, I think, with us providing that information. As long as people have got a current MasterMap license, then we're not giving them anything that they couldn't access anyway. So I don't see why not.
Brilliant. Okay. So looking back then at the data and the variables, question are there any moves towards drawing together shared terminologies, or is the future in accepting that different terminologies and instead doing the comparisons later on in the process of merging and interpreting that data?
I think that there will be at least an attempt to try and produce more shared terminologies. I was very struck reading the government's 25-year environment plan. It actually says very explicitly, we will draw up a national framework of green infrastructure standards. So I think that there is likely to be a significant attempt over the next year or two to try and do more in terms of defining, you know, typologies for green infrastructure and standards and so forth that can be used in these sorts of ways. If the government is serious about implementing some of the objectives in that 25-year plan, they will really need to put resource into that kind of activity.
Okay, brilliant. From somebody asking, obviously your work at the moment is focusing on those areas within the east of England, but if you're looking at taking that work over to cover any other areas such as Hertfordshire and into the other areas surrounding that east of England.
I think we would be very interested in trying to see what we could do in other areas. I mean, we've been able to invest in a spatial server so that we've now got the capacity to process data much more efficiently than we previously could. We'd be very interested in trying to collaborate with users in, for instance, other local authorities, if there are ways that we can try and do that, particularly if they've got some kind of green infrastructure database of their own, which we can use as a sort of verification basis. That would particularly be an interesting thing to try and do. But yes, I'm very open to those kinds of collaboration possibilities.
Excellent. Well, I think we've sort of come to a natural conclusion with all of the questions. There's been some really brilliant questions, some really big questions in there that Andrew's done fantastically well with. So I just wanted to say thank you very much to everybody for joining the webinar today. We really hope that you enjoyed the presentation. It gave you some food for thought. And thank you as well to Andrew, of course, for such an informative and engaging presentation. As I mentioned earlier, All of the slides will be available on our website soon if you would like to go online and download a copy, and a recording of the webinar with the slides will be available up on our website in a few days' time as well. So thank you very much to everyone who has joined us today. I hope you found it interesting, and we hope to see you at another webinar again soon. Many thanks.